So I think that the video got cut off, so we'll just do a quick review of stationary front, then we'll hit the last one, and then we'll move on. So a stationary front, if you look at the picture here, or if we even pull up the stationary front, we learned that a stationary front is when a warm front and a cold front, they don't necessarily catch up to each other. They kind of collide head on, right? You've got the warm front trying to move in this direction, the cold front trying to move in this direction, but neither one of these fronts have the ability to move the other one out of the way. And what happens is right here in the middle, obviously the warm air is going to go up, and there's going to be some from evaporation to condensation and precipitation. But because it doesn't move that much, these nimbostratus clouds that form are going to cause like days and days of rain, because the stationary front stays in its place for a very long time. And when we took our notes on the stationary front, we said that it has, now again, it's moving, isn't it? It's like this pushing back and forth, but it's not moving very far. And we have the two symbols in a stationary front because your warm front's trying to move in this direction and your cold front's trying to move in this direction. So we get those nimbostratus clouds and days of rain. Now, for some weird reason, I don't know why, but in my notes here, occluded front came first, and that should not be the case. Occluded front is probably one of the more tough ones. Occluded front is simply this. Remember when we were studying the warm front? The warm front has moved in, and it's kind of pushed up over top of, it's, you know, slowly moving its way up and over top of a cold front, right? Or a cold air mass. What happens in an occluded front is behind this warm front is another cold front that comes zooming in. So you've got basically what you would have is you've got cold air over here, right? You have your warm front that's moving in over here, and he's getting ready to start pushing, you know, up and over and causing those things. But in behind this cold is more cold air, and it catches up with that warm air and pushes it up. So you've got warm air going up over this, but then you got this sinking under this and pushing it up even quicker, right? And if you notice, look what color it turns when I have that blue and red kind of touching each other. It kind of turns purple. And if I take all this away, slowly, maybe, goodness gracious, did I really draw that many times? Oh, let's not do that. And I go back to this. If you notice right here, you have your occluded front symbol. And your occluded front symbol is simply this. That's not what I wanted, but I'll use that anyway. It's going to have this, but this.
Mr. Bowler?
Yes.
We have Haley Young's classes in the office.
Thank you.
Thank you.
And I'll color that in. So do you see the warm front symbol in there? Do you see the cold front symbol in there? I see them both. And we realized that when that cold front caught that warm front, we could see that the blue and the red, when you kind of mix those, we got a purple. Now, occluded fronts, let me pause this real quick. Sure, the people are home like I can't see the top of the board, Mr. B. Occluded fronts can have pretty severe weather with them. They can have very severe weather with them. Not every time are you going to have that, because again, you've got, it depends on how much moisture is in there, how fast they are moving, and how hard they collide. But when you have occluded fronts, because look at this, they commonly occur close to maturing low pressure systems. Well, how low of a pressure are we talking here? Because again, the lower we get, the more lousy we get, right? And we know that if we get really low on the pressure system, we can get some pretty severe thunderstorms. Occluded fronts can have severe weather with them, because it's a combination of two fronts that form when a cold front catches up and overtakes a warm front. When you have all that air masses moving and colliding like that, you can have some pretty severe weather that forms between those two. I'm going to pause that. And this. So as we've logged into our website, we've looked at what can happen with a warm front. And we notice that the warm front doesn't move super fast, does it? If it'll let me do it. Doesn't move super fast as it moves up. And it just climbs on the top of that cold front. And depending on how much moisture is in there, clouds form and maybe some nimbostratus clouds, Braden, right? When we noticed that the cold front was a little bit different, it moves a little bit faster. And as it sinks in and under that warm air, these big cumulonimbus clouds can form. When a cold front moves in, you can get some pretty bad storms. It just depends on, again, how much moisture is over here in this warm air and the temperature difference between those two and how much of a change in pressure you have. But again, you can see how those clouds build up pretty tall, giving us the chance of having some pretty bad storms. Stationary fronts. Again, I don't have to do anything with this one because it's stationary. They move back and forth a little bit. See that tiny bit of rocking back and forth? And we get those days and days of rain. And so that moves us to our occluded front. So here's my warm front. And we've seen this before, right? Where the warm air goes up and over the cold front. But with the occluded front is when another cold front that's coming behind it catches up to that warm front before it can move up and over. And it looks like this. And you see, like, again, you have the chance of it really building up to be a pretty bad storm, right? It depends on, again, how fast this is moving, how much moisture is in the warm air that's in here, and the temperature difference between these. But you can, it could just be this, but if this comes in super quickly, like that, you could get some pretty bad storms with an occluded front as well, right? Now, again, this website is there for you to use. Please use it. Please use it as you're going through and learning about these, all right? Because I think, for me, what does a warm front do? If I go in here and I'm moving this, okay, I remember a warm front. Actually making it happen really does tend to help me a little bit. It's got my symbols down here. It tells me what's going on. And I like this website. Not as much as the other one, but the other one doesn't work anymore. You can see the teeth. You can see what direction it's moving. Go to your stationary front. You don't do anything. You know, the warm air is moving this way. The blue is pointing this way, so it's moving this way, and it goes back and forth, and it's stationary. It doesn't move. And then you actually can move the cold air. And you see how this front catches this front and pushes it up into the air. And now you've got an occluded front. An occluded front. I don't think that those are super, super difficult. And we've got all of our notes in here that we've taken. So far I think we should feel pretty good about these, right? Now, in class, we're going to go back and watch all the videos. People at home need to do that. I can't play a video and record it and put it on my YouTube. That's pretty sure that's against the terms on YouTube for copyright laws, and I don't want to get in trouble. So I'm going to pause this, save it, and make it a video 2 for fronts. Post that in a little bit.